Now here we consider infinitesimal small element having length dr which is situated at distance r. So when this one is rotating, the EMF induced, that is dE, equal to BVdR. But V equal to R omega. So we can write this is equal to BR omega dr. Now, if we consider this type of so many infinitesimal small line elements on this conductor starting from O to P, and for each one if we calculate the EMF induced, and then after if we take the summation of all this, we will get the resultant EMF induced in that entire conductor. It implies that between this center and this circumference of the ring. So we have to integrate this equation and we have to take the elements starting from O to P. At O r equal to 0 and at P r equal to capital R, that is the radius of the ring. So we have to integrate this equation between the limits 0 to capital R. Now substitute here value of dE. B and omega are constant, so taken outside the integration. So we can write now integration 0 to R, R dr. Integration R, that is R square by 2. Now if we substitute the limits, then we will get E, that is B omega R square by 2. Clear? This one is the equation for the rotating rod in the magnetic field. This is one type of theory. આ equation ને તમે directly કોઈ problem solving માં પણ use કરવું હોય, provided કે situation આવી same આપેલી હોવી જોઈએ. Now the same equation that we can derive by another method also. Say, suppose here we connect resistance between O and P, and then the rod is rotated. Then at a certain instant, if the position of the rod is OQ, now if the rod is rotating, means this area subtended by the rod is continuously changing. So if area is changing, it implies that the flux associated with this particular loop, that is also continuously changing one. So definitely the EMF will be induced here between this point O and Q. It implies that across this particular conductor, the EMF will be induced. So let's first take flux phi. Flux, that is B into area of this particular closed loop OPQ, this one. Suppose that particular area is A, so we can write phi, that is B into A. Now this area is continuously changing, B remains constant. But after all, if area is changing, flux will be changing one. So EMF will be induced. So if we differentiate this equation with respect to time t, then we will get EMF. So magnitude of EMF, that is d phi by dt. B is constant, so we can write B into dA by dt. Now what is the value of A? Now suppose we consider this entire circumference of the ring, then circumference of the ring subtend angle 2 pi radian at the center. And if the angle subtended at the center is 2 pi radian, then the area swept, that is pi r square. So here if angle subtended by an arc is theta, then what is the area swept by it? So area, that is theta into pi r square upon 2 pi, pi cancel. So your area turns to half r square theta. Now if A is replaced by half r square theta, then half r square is constant, so take it outside the differentiation. So half b r square d theta by dt. but d theta by dt, that is angular speed. So E, that is b omega r square by 2. A same equation આપણે આ method થી પણ લઈ શકીએ છીએ. Now it is given to you B is 1 Tesla, R is 1 meter, and omega, that is 50 revolution per second. So multiply it by 2 pi to convert it in radian per second. And now substitute these three values of B, R, and omega in this equation. Then you will get the EMF. Clear to all of you? Then after, next example. A wheel with 10 metallic spokes each 0.5 meter long is rotated with a speed of 120 revolution per minute in a plane normal to the horizontal component of Earth's magnetic field HE at a place. If HE, that is 0.4 Gauss at the place, what is the induced EMF between the axle and the rim of the wheel? Note that 1G, that is 10 raised to minus 4 Tesla. એટલે જો હવે સિચ્યુએશન આપી છે આપણને, અહીંયા આપણે આજે એક રોડ લીધો તો this one, અને રિંગ ફિક્સ હતી, રોડ ફરતો હતો. આપણે રોડ ફિક્સ રાખીને રિંગ ફેરવીએ માનો કે, બરોબર છે. હવે પણ એની અંદર શું કર્યું છે, અહીંયા આગળ 1 2 પછી આવો અહીંયા 3 4 5 6 7 એવા 10 સ્પોક્સ આપ્યા છે. હવે આપણે વ્હીલને ફેરવીએ તો આ 10 spokes means 10 conducting rods are rotating, right? No doubt, when the rod is rotating in the uniform magnetic field perpendicular to it, then the EMF induced in the rod, that is B omega r square by 2. But here, total 10 spokes means 10 conducting rods are given to you. So be careful here. How the EMF is induced, that we discussed. But now we have to think about the polarity of the induced EMF in this particular example. Normally તમે ઉતાવળમાં શું કરી નાખો છો બેટા, કે 10 spokes આપ્યા છે તો આપણી પાસે એક રોડ માટે અથવા તો એક સ્પોક માટેનું ઇક્વેશન તો આ છે જ, half b omega r square. Let's multiply it by 10. એવું નથી કરવાનું આમાં. હવે જુઓ સિચ્યુએશન શું છે આખી. ચલો આ બધું તો ભલે એમ રહ્યું. હવે આ સ્પોક વાળો પોર્શન સમજીએ, રાઈટ? નાઉ સી, if this one is the rod rotating like this, it implies that each and every charge residing in this one, that is in motion. Now we know this thing, when any charge Q is moving in the magnetic field B with velocity V perpendicular to the field, then the force acts on it, that is QVB sin theta, but sin theta, that will be 1. So QVB. Now, if the charge residing in this particular conductor experiencing the force F, then as per the equation Q into V cross B, so with the help of right-handed screw rule, we can fix the direction of the force acting on that particular charge Q. And now, if we calculate that particular force with the help of right-handed screw, then we can understand the positive charge will experience the force towards the center, and negative will experience the force in outward direction. It implies that now, if in this particular conducting rod the EMF induced, that is half b omega r square, then we can say this thing, this particular rod itself behave as a battery having EMF equal to half b omega r square, for which the end towards the center is positive, and the end towards the rim, that is negative. But now see, for each and every rod, the situation is the same one. It implies that now see, all the positive terminals are connected at the center. All negative terminals are connected at the rim. It implies that this is nothing but the parallel combination of EMFs. And in parallel combination, if all the EMFs are identical one, same one, then the resultant that will remain the same one. It implies that the EMF between center and the rim, that will be the same one, half B omega R square. એટલે આમાં કોઈ 10 સ્પોક હોય એનું ઇમ્પોર્ટન્સ રહેતું નથી. બસ હવે સિમ્પલ થઈ ગયું એક્ઝામ્પલ. Induced EMF, that is half B omega R square. Substitute the value of R 0.5 meter. Omega is given to you 120 revolution per minute. So multiply it by 2 pi by 60. So you will get omega in radian per second. Then B, that is given to you, that is 0.4 Gauss. So 0.4 into 10 raised to minus 4 Tesla. And now substitute these three values here. You will get the answer. Clear to all of you? Any doubt in this one? Now see, energy consideration, a quantitative study. We already discussed this thing, the motional EMF, that is BVL. In the previous theory, we discussed this thing when the rod is moved on the arms of the U-shaped frame like this, then the EMF induced between these two ends of the rod, that is BVL. Now, due to this particular EMF, here the current will be constituted in this particular loop. So we can say, when current I is flowing through this conductor and conductor itself is in the magnetic field, so now force will act on it. Now force on the current carrying conductor placed in the magnetic field B, that is BIL sin theta. But here theta is 90 because magnetic field is perpendicular to the plane of paper and the current is in the plane of paper. So theta is 90, sin 91. So simply we can write the force X, that is F equal to BIL. Now this particular force, that will be in such a direction so that it will oppose the motion, because Lenz's law is always present, and Lenz's law says this thing, the polarity of the induced EMF will be such that it will oppose the cause of its production. Clear? So this particular force will oppose the motion. Now here, the current constituted in this particular loop, that we can write I equal to E by R. So R, that is the resistance of the loop PQRS. So now we can write this force X on the conductor, that is B, I is replaced by E by R into L. So F, that is equal to B into, now E is replaced by BVL upon R as it is, this L as it is. So finally your equation for the force turns to B square VL square by R. Now this is the force which one is opposing the motion. it implies that if you want to sustain the motion of this rod with constant velocity v, then you have to exert external force, which one should be exactly equal to this particular resistive force. આ force ને lens force પણ કહેવાય છે because it is opposing the motion. Now, the mechanical power consumed to sustain the motion of the rod with constant velocity, that is, power is force into velocity. So force, that is b square v l square by r into velocity v. So we can write mechanical power, that is b square v square l square by r, equation number 1. Now the electrical power induced, that we can write E square by r, but E equal to bvl whole square by r. So electrical power, that is b square v square l square upon r. So here actually we consider the ideal situation, so means the dissipation of energy in the form of heat is neglected. But see here now, if we consider the ideal situation, then we can see equation number 2 and equation number 2 are same one. So mechanical power consumed, that is equal to electrical power induced. It implies that here the electrical energy obtained, that is at the cost of mechanical energy, at the cost of mechanical energy. Now here we can obtain one interesting relationship, the relationship between charge flow through the circuit, or we can say that closed loop, and the change in magnetic flux. Now see, we have the equation of the magnitude of EMF induced, that is delta phi by delta t. But EMF, that is equal to IR also. So we can write IR, that is equal to delta phi by delta t. Now, I, that is delta Q by delta t, in chapter number 3 we studied this thing. So if I is replaced by delta Q by delta t, R is as it is, that is equal to delta phi by delta t. Delta t cancelled. So delta Q equal to delta phi by R. This one is the relationship between the charge flowing through the circuit, or we can say through that particular closed loop, and the change in magnetic flux associated with that particular closed loop. Clear to all of you? Now then, this example we'll discuss later on. Now let's think about eddy currents. Okay. Now see, we already discussed this thing. If the flux associated with the loop changes, then EMF is induced in the loop, and due to that the current is constituted in the loop. Now we can change this flux associated with the loop by moving the loop in the field, or by keeping loop constant and by changing the magnetic field. By any means, you can change the flux associated with it, and the EMF is induced in it, which constitute, or we can say which produces current in it. Okay. But see here, if bulk matter is placed in the magnetic field and moved in it, then in that also the EMF is induced, which produces the current. But this current produced in bulk matter are whirling currents, means they form small loops, whirling or circulating like this. And these whirling currents are known as eddy currents. Are known as eddy currents. Bulk matter means, suppose we take a metallic plate, and that particular metallic plate is moved in the magnetic field, or we can say is subjected to the changing magnetic field, then this thing is observed in it. But now important thing is this one. This particular eddy currents, as per Lenz's law, will oppose the cause of its production. Now let's try to understand this thing with example. Suppose we take one plate like this, and this particular plate, that is suppose oscillated in the magnetic field. Suppose it is oscillated in the magnetic field like this, in this way. Clear? Now see the figure in the text. So magnetic field is produced with the help of two poles, and in that particular magnetic field this plate is oscillated. But when the plate is entering to the field, at that time the flux passing through it, that is increasing one. No doubt EMF will be induced, which will produce the eddy currents. Suppose arbitrarily we consider this thing. At that time, those eddy currents are produced in clockwise direction, suppose. Then from other end, when your plate is leaving the field, at that time the flux passing through it, that is decreasing one. So here the current produced will be in opposite direction than initial one, means now the current produced will be in anti-clockwise direction. And as per Lenz's law, this current will oppose the cause of its production. At present, the cause of the production, that is the oscillations of the plate. So those oscillations will be opposed. Means the oscillatory motion will be opposed. It implies that the motion of that plate, that will be damped motion. It implies that its amplitude will be continuously decreasing one. And this type of damping, that is called electromagnetic damping. That is called electromagnetic damping. Clear to all of you? Any doubt in this one? Now, these eddy currents will oppose the motion, as well as when this current are produced, then whatever the path is chosen by current to form the loops, but on that particular path definitely some resistance will be there, and due to that resistance offered to those eddy currents, as per I square RT, heat will be generated. So some part of energy that will be dissipated in the form of heat, as well as per Lenz's law, it opposes the motion. So these are the disadvantages of eddy currents. But now if you want to minimize the effect of these eddy currents, then what you have to do, see the second figure in the text. We have to make slots in the metallic plate. See, suppose this one is the plate. This one is the plate, right? And it is oscillating like this. So eddy currents are generated, suppose in this way. Okay. But now suppose like this, the slots are made. આપણે અહીંથી આમાં બધા કટ મૂકી દઈએ આ પ્લેટ ઉપર. તો શું થશે? Eddy currents will be cutted and loops will be smaller one. So effect that will be minimized one. Okay. Now, no doubt, it opposes the motion, heat is generated, but then also scientists developed some applications of eddy currents also. And these applications compulsorily you have to remember, you have to mug up these things. See, eddy currents are used to advantage in certain applications like, see, first one, that is magnetic braking in trains. Strong electromagnets are situated above the rails in some electrically powered trains. When the electromagnets are activated, the eddy currents induced in the rails oppose the motion of the train. As there are no mechanical linkage, the braking effect is a smooth one. So this one is its first application. Second one developed, that is electromagnetic damping. So electromagnetic damping are also useful in galvanometer. Certain galvanometers have a fixed core made of non-magnetic metallic material. When the coil oscillates, the eddy currents generated in the core oppose the motion and bring the coil to rest quickly. Otherwise, that coil will continue its oscillations. Then after, induction furnace. Induction furnace can be used to produce high temperatures and can be utilized to prepare alloys by melting the constituent metals. A high frequency alternating current is passed through a coil which surrounds the metals to be melted. The eddy currents generated in the metals produce high temperature sufficient to melt it. So when high frequency alternating current is passed through the coil, so that high frequency alternating current will produce the continuously changing magnetic field. So if that metallic slab is subjected to that continuously changing magnetic field, then eddy currents will be generated in that metallic slab, and those eddy currents generate the heat. And with the help of that heat, it will be melted. Then electric power meter. The shiny metal disc in the electric power meter rotates due to the eddy currents. Electric currents are induced in the disc by magnetic fields produced by sinusoidally varying currents in a coil. This sinusoidally means alternatively changing, which are following the sine or cosine type periodic functions. So periodically changing, that is called sinusoidally changing. So these are the applications of eddy currents. Inductance. Now see, suppose we consider any solenoid having total number of turns n. So we know this thing, when the current is passed through it, the magnetic field is produced by the solenoid, and these magnetic field lines passes through the solenoid. It implies that we can say some flux is associated with it. Now, if total number of turns in the solenoid is n, then the total flux associated with it that we can write n phi. And experimentally we can observe this thing, this n phi directly proportional to the current. If current is increased, then the flux associated with it will increase. Clear? Now, here on right hand side of this equation, we have to introduce a proportionality constant. So we can write n phi b equal to, here some constant into I. That particular proportionality constant, that is called inductance of that coil, and the coil is also known as inductor. Now from this particular equation you can give the definition of inductance like this. If we take I on left hand side, then your right hand side, that is inductance, that constant one. Okay, so we can write the definition like this: the total flux associated with the inductor per unit current passed through it, that is called inductance of that particular inductor or coil. And the inductance of the coil, that depends on the geometry as well as geometry of the coil, as well as the type of the core material on which the coil is wounded. Okay. Now here we have to discuss two types of inductances. One that is mutual inductance, and second one that is self-inductance. Okay. Now see, before deriving the equation for mutual inductance, first understand mutual induction. So mutual induction, that is the phenomenon. Now see, suppose we take a system of two coils. We take a system of two coils. Now, if current is passed through any one coil, then that particular current carrying coil will produce the magnetic field, and those magnetic field lines passing through that another coil will associate some flux with that another coil. So current is passed through one coil and flux is associated with the second coil. Now, if the current flowing through the first coil is changed, then the flux associated with the second coil will be changed, and due to change in the flux associated with the second coil, the EMF will be induced in the second coil. This phenomenon is called mutual induction. So now we can say like this: for a system of two coils, if current is passed through any one coil, the flux will be associated with other one. And if current passed through the first one is changed, the EMF is induced in the other coil. This phenomenon, that is called mutual induction. એકમાં કરંટ પાસ કર્યો છે તમે ને બીજામાં EMF induced થાય છે. So that is the mutual interaction between these two coils. So it is called mutual induction. And now we have to derive the equation for the mutual inductance for the system of these two coils. Now for simplicity in calculations, we consider two solenoids which are coaxial, having lengths L each one. Solenoid S1, that is with radius equal to R1, and the number of turns per unit length of solenoid S1, that is N1. For solenoid S2, the radius is R2 and number of turns per unit length, that is N2. Now, if I2 current is passed through the solenoid S2, clear? Then flux will be associated with solenoid S1. So flux associated with solenoid S1, that is N1 phi1. Phi1, that is the flux associated with each turn, and N1, that is the total number of turns in the given solenoid. So total flux associated with solenoid S1, that directly proportional to the current passed through second one. So here we introduce the proportionality constant M12. Mutual inductance is denoted by capital M. Always remember this thing. And this 1, 2 in suffix represent this thing. This is the mutual inductance of solenoid S1 with respect to solenoid S2. Clear? Okay. Now, N1, that is the total number of turns in S1. But if number of turns per unit length is a small n1 into total length L we take, then that will give you the total number of turns. Now we can write N1 phi1, that is N1 L into, now this flux phi1, that is B2 A1. B2, that is the magnetic field produced by solenoid S2, કારણ કે current એમાંથી પાસ કર્યો છે આપણે. And we are calculating the flux associated with S1. So cross-sectional area, that is of S1. So we can write N1 L1. Now magnetic field produced by the solenoid, that is mu 0 Ni. So this magnetic field is produced by S2, so mu 0 and 2 I2. And cross-sectional area of the first one, so pi R1 square. So N1 phi1 equal to mu 0 N1 and 2 L pi R1 square into I2. Now if we compare this equation number 1 and 2, then we can write M12, that is this part, mu 0 N1 and 2L into pi R1 square. Say this is equation number 3. Clear? So આ થઈ ગયું mutual inductance of solenoid S1 with respect to solenoid S2. Okay? હવે જો આપણે current through solenoid S2 change કરીએ તો obvious છે first સાથેનું flux change થશે અને first માં EMF induce થશે. So N1 phi1 equal to, અહીંયા M કેમ લખ્યું છે એ આપણે આગળ ઉપર ડિસ્કસ કરીએ, કારણ કે તમને એમ થશે કે M12 ની જગ્યાએ સરે M કેમ લખ્યું એમ, બરોબર? તો અત્યારે ટેમ્પરરીલી તમે આ M12 છે એવું જ ઇમેજિન કરીને ચાલો. Okay? So now differentiate this one with respect to time t. So N1 d phi 1 by dt equal to M di2 by dt. Introduce negative sign on both the side. So M minus N1 d phi 1 by dt, that is minus M di2 by dt. So left side is nothing but the EMF induced E1, that is minus M di2 by dt. આના ઉપરથી પણ મ્યુચ્યુઅલ ઇન્ડક્ટન્સની ડેફિનિશન અપાય. per unit rate of change of current in either of the coil, the EMF induced in the other coil, that is called its mutual inductance. હવે અત્યારે આપણે શું કર્યું, S2 માંથી કરંટ પાસ કર્યો અને S1 સાથે એસોસિએટેડ ફ્લક્સ કર્યું. હવે આપણે એવું કરીએ કે S1 માંથી કરંટ પાસ કરીએ અને S2 સાથે એસોસિએટેડ ફ્લક્સ કરીએ. So current is passed through solenoid S1. Total flux associated with S2 N2 phi 2 directly proportional to I1. So N2 phi 2, that is M21 I1, this proportionality constant, that is called mutual inductance of S2 with respect to S1. N2, that is total number of turns in S2. So we can write that is small n2 into L. Now, as per definition, we can calculate this flux, total flux. So N2, that is N2L, flux, that is B1A1. B1, that is the magnetic field produced by solenoid S1. We are calculating the flux associated with S2, but here we are not taking the cross-sectional area of S2, but we are taking the cross-sectional area of S1. Why? See, current is passed through this small solenoid S1, and we want to calculate flux associated with this larger one, but we already studied this thing. Magnetic field outside the solenoid is zero. The magnetic field produced by this S1 between these two, આ બેની વચ્ચેની આ જે સ્પેસ છે ને એમાં ફિલ્ડ હોય જ નહીં. એટલે આ જે સ્પેસ છે એની સાથે કોઈ ફ્લક્સ એસોસિએટ નહીં થાય. ફ્લક્સ જે એસોસિએટ થશે ને એ આટલા પોર્શનમાં થશે ખાલી, અને એટલા માટે આપણે A1 લીધું ત્યાં. તો B1 A1 N2L mu 0 N1 I1 A1, that is pi R1 square. Finally, you can write mu 0 N1 N2L pi R1 square I1. Compare equation number 4 and 5. You will get M21, that is mu 0 N1 N2L pi R1 square. But this equation number 6 and previously obtained this equation number 3, both are same one. Both are same one. So M12 equal to M21, and therefore we say it is capital M. It implies that the mutual inductance of 1 by 2 or mutual inductance of 2 by 1, that is after all one of the same thing, right? So now collectively we have to say mutual inductance of a system of two coils. Clear? અને એટલા માટે આપણે આગળ M લખ્યો હતો. હવે યુનિટ તો આ પ્રમાણે લખીએ તો આનો યુનિટ વેબર, કરંટને અહીંયા નીચે લઈ લો તો વેબર પર એમ્પિયર, but Weber, that is Tesla meter square upon ampere, and that is called Henry. એનો ત્રીજો યુનિટ અહીંયા લખવો હોય તો લખાય as per this EMF. અહીંયા પણ EMF માટે N2 phi 2 MI1 ડિફરન્શિએટ કરો, નેગેટિવ સાઇન આમાં લઈ લો. હવે EMF નો યુનિટ વોલ્ટ, ટાઈમ આ બાજુ લઈ લો તો સેકન્ડ, અને આ કરંટ અહીંયા નીચે લઈ લો તો વોલ્ટ સેકન્ડ પર એમ્પિયર, એટલે 4 યુનિટ થશે. હેનરી વેબર પર એમ્પિયર, ટેસ્લા મીટર સ્ક્વેર પર એમ્પિયર, that is equal to volt second per ampere. બરોબર છે? આ ટેક્સ્ટમાં છે ને થોડું ઓર્ડ રીતે આપ્યું છે, આ લખી નાખો કમ્પ્લીટ. અરે અને ફિગર હા તમારે 2 દિવસ એના તે સેટરડે પરમેનન્ટ બારનું પત્ર કામ દીધું એમાં કોઈ ચીજ નથી એચઓડી ઇન્ટિરિયર સેકન્ડ તે સેટરડે કે કોઈ ચિંતા નથી અને સન્ડે નું લેક્ચર રહેશે એમસીક્યુ ની પ્રેક્ટિસ માટેનું બરાબર એ હશે 12:30 થી 2 વાગ્યા સુધીનું અત્યારે 12:45 થી 2:15 સુધી ચાલે છે અને 15 મિનિટનો બ્રેક એટલા માટે વચ્ચે લેવો પડે છે એટલે આઈડી ને પાસવર્ડ મોકલીએ ને પાછા એન્ટર થાય છે બધું થાય છે ને પ્રોસેસ અત્યારે કન્ટિન્યુઅસલી ઓનલાઈન હમણાં તો ચાલશે આજે જ મેં સવારે લોકોને સમજાયું કે હજી 15-20 દિવસ તમારા લેક્ચર એક્સ્ટ્રા ચાલશે ત્રણ ચેપ્ટર આજે ભણવાના છે એટલે 3 ચેપ્ટર છે એટલે પાછળ શું એક્ઝામ બહુ જ આવે છે અમારા ફિઝિક્સમાં એટલે બીજું એના માટે કરીને ખાસો ટાઈમ લાગશે અરે પ્રુવિંગ બસ પૂછતા રહેવાનું બે શેર આપી દે અને જો આજે તમે જોયું કે ક્યાં પેલી બેબીએ 2 વખત પૂછ્યું કે આખું ફરી ના સમજાય અને હું શું લે રોજની એક ઇલેવનની અને એક 12ની હવે અત્યારે આજુ 12 વાળા તો તમને બી એનો ટાઈમ આપી શકાય બાળકોને એના માટે આપણે લિમિટેડ વર્ક કરીએ છીએ પછી ગમે ત્યારે ધારો કે પેરેન્ટ્સને સામે મળવું છે તો એ પણ થશે અને હવે એ લોકોને કેવું છે મારે એવું છે કે જેમ જેમ ચેપ્ટર ચાલશે એમ કાયમ ટેસ્ટ હોય બરોબર છે એટલે આગળની ટેસ્ટ આપણે પછી લઈશું એ લોકોની અત્યારે હવે જે કાલથી ચોથું ચેપ્ટર આજે તો હજી 3જા ચેપ્ટરનું રિવિઝન છે આજે તમારી બેચ 2:30 થી 4ની હોય રેગ્યુલરમાં બરોબર છે પછી ઓફલાઈન જ્યારે થશે ને ક્લાસ ઉપર ત્યારે 4 થી 7 થઈ જશે બરોબર છે તો 2:30 થી 4 આપણે આજે જે ભણવાના છીએ એમાં 3rd ચેપ્ટરનું રિવિઝન કરાવવાનું છે બધાને અને પછી નેક્સ્ટ ટાઈમથી 4th ચેપ્ટર ચાલુ થઈ જશે એટલે જેવું ચેપ્ટર ચાલુ થશે એટલે શનિવારે જે ભણીશું એની સીધી એના તે ટેસ્ટ આવશે એના તે જે ભણીશું એની પાછી સેટરડે ટેસ્ટ આવશે અને વિના પરીક્ષા કરે છે તો પેલાથી વિષય તમે 3-4 વર્ષ તમારે લાગી જવાનું પછી શું કરવાનું કે એવરી વીક જે પેપર થાય બે પેપર આવતા જતા અહીંયા આવતા જવાના એની ચેક કરી રેડી રાખશે નેક્સ્ટ વીકના પેપર જ્યારે આપવા આવે ત્યારે આગલા વીકના પેપર ચેક થઈ જાય રેડી બને બરોબર છે અને અમે અહીંયા શું રિઝલ્ટ આખું મેન્ટેન કરીએ છીએ કે 1 મહિનાની અંદર 7 થી 8 એક્ઝામ આપણે થાય માનો અને એની અંદર જો તમારું એવરેજ રિઝલ્ટ સારું ના હોય તો પછી મારે મેડમની કરવા પડશે બોલાવવા પડે તમારી જોડે એમાં જો આપણે વઢવાટ કરવાનું હોતું નથી પણ આપણે ડિસ્કસ કરીશું બધા બેસીને કે રિઝલ્ટ કેમ સારું ડાઉન આવે છે અને હવે આને ઇમ્પ્રૂવ કરવા માટે આપણે શું કરી શકીએ
એના માટે અમને એમ જ પૂછ્યું કે ડે ટુ ડે પ્રિપેરેશન થતી જાય તો કોઈ પ્રોબ્લેમ
એ
ના
તો
આવે.
એ જ જરૂરી ભણવાની અમુક પદ્ધતિઓ છે એ પદ્ધતિઓને હવે તમારે તો ઘરમાં ટીચર છે એટલે બધી પદ્ધતિઓ ફોલો કરો ને તો જ સક્સેસ મળે. બાકી એક વસ્તુ નક્કી એમ દીધો તમે કે જે લોકો માર્ક લાવે છે ને જે માર્ક નથી લાવતા ને એના આઈક્યુમાં બી લાંબા ફરક હોતા ફરક એટલો જ છે કે જે માર્ક લાવે છે એ લોકો કન્સિસ્ટન્ટલી મહેનત કરે. એમની હવે એક અઠવાડિયું આરામ કર્યો, નેક્સ્ટ વીક ખેંચી નાખીશું, પાછું એક અઠવાડિયું આરામ. આજે ભણ્યા બધું આજે રોગે રોજ કમ્પ્લીટ અને વારંવાર રિવિઝન. દર મહિને આપણે જ્ઞાન ટેસ્ટ આવશે એની અંદર આપણે બધા ચેપ્ટર કેટલા ચાલ્યા હોય કેટલાની ટેસ્ટ આવશે.
ઓકે ચલો
ચાલો થઈ ગયું.
સર
તો બેટા
અમિતને અંદર લો ને એ વેઇટિંગ રૂમમાં છે.
અહીંયા તો વેઇટિંગમાં એક જણો દેખાતો નહીં લ્યા.
સર એનો મેસેજ આવ્યો કે એનો વેઇટિંગ
એટલે
આવી ગયો સર, આવી ગયો.
હા self-inductance. Suppose we consider only one coil, means only one solenoid, and that one is connected with battery. And now suppose the current is passed through that solenoid, then that solenoid will produce the magnetic field, and due to magnetic field produced by itself, some flux will be associated with that solenoid itself. And here also we can observe the total flux associated with the solenoid or passing through the solenoid that directly proportional to the current passed through it. So here on right hand side, the proportionality constant which we introduced, that is called self-inductance of the coil. It is denoted by capital L. આમાં એક જ coil લેવાની છે આપણે. Now, if we calculate this flux by definition, then N is total number of turns, Suppose number of turns per unit length is a small n and length of the solenoid is L, then capital N, that is NL. Flux phi associated with each turn, that is B into cross-sectional area. So N phi, that is NL, B, that is mu 0 Ni into A. So we can write N phi, that is mu 0 N square AL into I. Now if we compare these two equations, then we can write L equal to mu 0 N square A into L. Clear? So this one is the equation for self-inductance. Now we have N phi, that is Li. Differentiate this one. So N d phi by dt, that is L di by dt. Introduce negative sign on both the side. So we can write now E, that is minus L di by dt. This E, that is called self-induced EMF. આગળની થિયરીમાં જે આપણે ડિસ્કસ કર્યું એમાં જે EMF છે એને કહેવાય mutual induced EMF. This one is a self-induced EMF. This is also called back EMF. Why it is called back EMF? Because here Lenz's law is present, see. So this EMF induced in the solenoid will produce the current in the direction so that it opposes the change in current in the solenoid. એટલે આપણે સોલેનોઇડમાં જો કરંટ ઇન્ક્રીઝ કરતા હોઈએ તો આ જે EMF છે એ જે નવો કરંટ કન્સ્ટિટ્યુટ કરશે એ એની ઓપોઝિટ ડાયરેક્શનમાં કરશે એટલે કરંટને ડિક્રીઝ કરવાનો ટ્રાય કરે. If we are decreasing the current, તો પછી કરંટની ડાયરેક્શનમાં જ કરંટ કન્સ્ટિટ્યુટ કરશે એટલે એ એને ઇન્ક્રીઝ કરવાનો ટ્રાય કરે. In short, it will oppose the cause of its production. Therefore, it is also known as back EMF. It is also known as back EMF. Now see, in the same one, the next theory, that is the energy stored in the inductor. See, just like capacitor, this one is also energy storage device. In capacitor, the energy is stored in the form of electric field. In inductor, the energy is stored in the form of magnetic field. Now see, at any instant, if the current I is there in the inductor, then we can say the power, that is E into I, and the power, that is nothing but the rate of work done. Okay. Now E, that is L di by dt, that is L di by dt. આપણે magnitude wise લીધું છે એટલે negative sign એ લેતા નથી અત્યારે. Okay. Now, due to this back EMF, see, as soon as we start the current in the solenoid, we start the current from 0, immediately the back EMF will be induced in it, which will oppose this change. So if you want to establish the current from 0 to I, then you have to do work against this back EMF, against this back EMF. So here, if you want to change the current by di, then we can write dt cancelled. So dw, the work done against the back EMF, that is Li di. So if you want to establish the total current I, then the total work done, that is integration dw, L integration I di, 0 to I, integration of I, that is I square by 2. So W, that is half Li square or Li square by 2. And this work done against that back EMF, that will be stored in it in the form of magnetic potential energy. So we can say the magnetic potential energy stored in the inductor when the current I is flowing through it, that is half Li square. This is just like half mv square. Here, This self-inductance L represents inertia in the circuit because these have the tendency to oppose the change. That is called inertia. The same that we discussed for mass. Mass is such a quantity which always opposes the change in the position of the object. We say mass represents inertia. So there is the analogy between mass and self-inductance. Clear? Mass represents inertia in mechanics and self-inductance represent inertia in electrical circuits when inductor is connected in it. Clear to all of you? Then this one is one simple example. If we consider current is flowing through both the coils in a system of coils, then in that particular case, if you want to find the EMF in either of the coil, then N51, suppose we think about the flux associated with first coil, then by itself means by the current flowing through itself, we can write here M11, that is L itself, self-inductance into I1. And due to second coil, M12, I2. That we already discussed. એનું summation લઈ લીધું આપણે. Now, EMF induced in this one, that is minus L di1 by dt minus M12 di2 by dt. The same you can write E2, that is minus L2 di2 by dt and M21. એટલે અહીંયા તમે M12 કે M21 ની જગ્યાએ પછી M લખી નાખો તો ચાલે. અહીંયા છે ને તમે 1 લખજો, રહી ગયું છે. 1 self inductance of coil 1 અને પછી માનો કે બીજી કોઇલ માટે તમારે આ EMF નું ઇક્વેશન લખવું હોય તો તમારે અહીંયા આગળ L2 લેવાનું, અહીંયા M21 લેવાનું, but M12 and M21 that is one of the same thing, એટલે ચાલશે.